Hi everybody, this video is going to talk about how we graph linear functions. And we're going to start off with how would we graph a linear function if it's already in slope-intercept form, and then we'll talk about how we would graph one that's, well, it doesn't start off in slope-intercept form, but we'll have a couple steps to put it in slope-intercept form before we actually graph. So the easiest example that we can have is something that's already in slope-intercept form. Okay, whenever we have something written in this form, our y-intercept is given by the 3 here, our slope is given by the number in front of x, which would really be -1. We can use those two pieces of information to actually graph. So I'm always going to start by plotting my y-intercept. So remember, this is my y-axis. My y-intercept gets plotted on the actual axis at that value, so +3. Then we use our slope, which in this case is -1, and I'm going to put that over 1. We use our slope to get other points on the line. The slope tells how far we need to go up or down and then over. So think rise over run. So if I have -1 for my rise, that means I go down 1 and then right 1. So I'm going to start at my y-intercept, go down 1, right 1, and plot a point. And I'm going to continue this pattern of down 1, right 1 until I extend it all the way to the edge of my coordinate plane. Now, I can also go backwards. So let's start back up at our y-intercept of 3. If I wanted to go left, I would have to do basically the opposite pattern. Instead of going down 1, right 1, I would go up 1, left 1. And I could continue this pattern. Notice my points should continue to lie in a straight line. And once we have them, we can connect. And there is the graph of this function. So let's do another example here. So we have a y-intercept of -4. So I'm going to plot my y-intercept at -4. My slope is 3. I'm going to write that as 3 over 1. So I'm going to start at my y-intercept. I'm going to go up 3, right 1, up 3, right 1, up 3, right 1. Okay, and that's as many points as I can fit on my coordinate plane. So I'm going to connect. Ooh, that is not a very straight line. We're going to connect. Hopefully your line looks better than that. And that's our graph. Okay, another example. Y-intercept at 2. Okay, this time my slope is already written as a fraction, so the rise is 2, the run is 5. So I'm going to start at my y-intercept, go up 2, right 5. Now I can go left with this as well. Instead of going up 2, right 5, we can go down 2, left 5 to get another point. So now we can connect, and there's our graph. So each time we're plotting the y-intercept and then using our slope to get to the next point on this line. Now, let's look at an example where it doesn't start in slope-intercept form. Okay, this is what we would call standard form. And the first thing I want to do is I want to get this in slope-intercept form by solving for y, which means get y by itself. So let's just think about this as an equation for a second. To get y by itself, we'd have to start by subtracting x from each side. That would leave us with 2y equals -x plus 4. And then I would have to divide everything by 2. So if I divide by 2, here it's going to cancel. And then I have to divide this by 2 and this by 2. Now keep in mind this is a -1x. So on the left side, these canceled, we're left with just y. -1x divided by 2 is really just -1/2x. And 4 divided by 2 gives us 2. So here is our equation now after it has been rewritten or rearranged into slope-intercept form. So again, we can graph by plotting our y-intercept and then using our slope to get to the next point. In this case, we go down 1, right 2, down 1, right 2. Or if I wanted to backtrack, I could go up 1, left 2, up 1, left 2. And then we can connect and we have our graph again. So if it doesn't start off in slope-intercept form, you need to get it into slope-intercept form to help you graph, because you need to know your y-intercept, and, well, you're not going to know what your y-intercept is until you get it into slope-intercept form. Now, let's say we're given a graph and we want to write a linear equation for that graph. We could start by identifying the slope of the graph and the y-intercept of the graph, and then we can simply substitute those values into our slope-intercept form for the slope and the y-intercept. So let me show you a couple examples of how we would do this. Okay, here's my graph. I want to know what's the equation for this graph. So I need to start by finding my slope. Remember, we go left to right. So we would have to go up 3, right 1, which means my slope is 3 over 1, which is really just 3. My y-intercept is down here at negative 3. So my equation using that information would be y equals, okay, my slope was 3, so 3x. My y-intercept is negative 3, so 3x minus 3. Okay, another example. Again, I need to start by finding my slope. So I go up 2, right 5. So my slope, I'm going to write this off to the side here, is 2 over 5, which doesn't reduce. We have a y-intercept of positive 2, so that's b. So the equation, y equals m, which is 2/5, times x, plus b, which is 2. So our equation is y equals 2/5 x plus 2. All right, I hope this video helped you. If you need to rewatch, pause, rewind, do that, and please ask questions. Have a great day.